December 8, 1941. Pearl Harbor's waters still churn with oil, bodies, and debris. Captain Homer Wallin stands on the dock, staring at what appears to be the graveyard of American naval power. 5 battleships rest on the harbor floor, twisted steel coffins filled with salt water and the dead. USS West Virginia sits crumpled like a discarded tin can, her port side ripped open by 7 torpedo strikes. USS California lists at an impossible angle, surrendering slowly to the harbor bottom. USS Nevada, beached and burning, leaks toxic gases that can kill a man in seconds. Japanese commanders have already radioed Tokyo, celebrating the destruction of America's Pacific might. But Wallin sees something different. He sees 30,000 tons of recoverable steel. He sees gun turrets that can still fire. He sees what the Japanese don't. These ships aren't destroyed. They're just sleeping. The question isn't whether these vessels can be raised. The question is whether anyone has the audacity to try. The mathematics of Pearl Harbor appeared catastrophic and final. 8 battleships damaged. 4 sunk outright. Over 2,400 Americans dead. Japan's naval planners had calculated their strike with surgical precision, cripple America's battleship force, buy 6 months for territorial expansion, force a negotiated peace before American industry could respond. On paper, the plan had worked flawlessly. Admiral Isoroku Yamamoto's staff had studied American shipbuilding capacity. They knew the United States could eventually outproduce Japan by staggering margins, but production meant nothing if the ships resting at Pearl Harbor could never fight again. The Japanese had effectively removed 8 battleships from the war, or so intelligence reports claimed. Tokyo newspapers already printed victory editions showing the burning wrecks. But those intelligence reports contained a critical miscalculation. Pearl Harbor wasn't the Atlantic Ocean. The average depth where the battleships sank measured just 40 feet. California's main deck sat completely submerged, but her superstructure still broke the surface. West Virginia had settled upright into the mud, her tripod masts reaching skyward like iron tombstones. These weren't ships lost to the abyss. They were vessels resting in shallow graves. Admiral Chester Nimitz arrived at Pearl Harbor on Christmas Day, 1941, to assume command of what remained. He walked the docks with Captain Wallin, surveying the damage. Wallin had served as battle force material officer. He knew every rivet, every compartment, every structural weakness of these ships. He understood something that escaped most observers. Modern battleships were designed to survive torpedo damage. The problem wasn't whether these vessels could theoretically float again. The problem was no one had ever attempted salvage operations at this scale, under these conditions during wartime. The Navy Yard at Pearl Harbor had survived the attack largely intact. Japanese planners had focused on the battleships themselves, ignoring the repair facilities, the massive cranes, the dry docks, and most critically, the fuel storage tanks. The infrastructure that could rebuild a fleet remained operational. Thousands of skilled welders, electricians, and engineers stood ready. The tools existed. What didn't exist was a precedent. Wallin presented Nimitz with a proposal that bordered on madness. He would refloat every salvageable battleship using techniques no one had tested at this scale. He would build wooden cofferdams around ships sitting underwater. He would patch holes large enough to drive trucks through. He would pump millions of gallons of water from flooded compartments while simultaneously managing toxic gas hazards that had already killed salvage workers. He would accomplish this while supporting an active fleet preparing for offensive operations. Nimitz approved the plan immediately. The alternative meant conceding half the Pacific to Japan. The challenges extended beyond engineering. Navy and civilian divers would need to descend into spaces filled with fuel oil, seawater, and hydrogen sulfide, a deadly, odorless gas created when oil and polluted saltwater mixed under pressure. On February 7, 1942, during Nevada's Salvage, one sailor opened a gas-filled compartment and collapsed dead within seconds. 5 more sailors rushed to save him and also collapsed. Only 4 recovered. From that point forward, no worker entered any compartment without a gas mask and litmus paper badges to detect invisible poison. The work would require approximately 20,000 hours of underwater diving time. Divers would make roughly 5,000 individual descents into oil-fouled waters where visibility measured in inches, not feet. They would work in complete darkness inside ships' hulls, feeling their way through twisted metal while toxic fumes accumulated above the waterline. The margin for error approached zero. Traditional salvage doctrine called for sealing torpedo holes with steel plates welded underwater, an impossibly slow process. Wallin's team developed an alternative: massive wooden cofferdams built around entire sections of damaged hull. These structures would extend from below the waterline to well above it, creating watertight barriers that allowed pumps to remove water faster than it leaked back in. Each cofferdam required precise carpentry performed while floating on unstable platforms, with measurements taken by divers groping through murky water. The Navy didn't possess adequate pumping capacity for operations this massive. Wallin requisitioned every available pump from the mainland and had engineers modify them for saltwater service. The largest pumps could remove 10,000 gallons per minute, but California alone contained over 200,000 gallons of contaminated fuel oil mixed with seawater. Each ship would require weeks of continuous pumping just to reach a neutral buoyancy. Then came the bodies. 70 men remained entombed inside West Virginia. Some had survived for days in airtight compartments. Salvage crews found a calendar with dates scratched off through December 23, 16 days after the attack. The psychological toll of recovering remains while simultaneously racing to prepare these vessels for war fell hardest on the youngest sailors. Many of them were teenagers. Skeptics abounded. Secretary of the Navy Frank Knox had officially declared Oklahoma and West Virginia total losses. Japanese intelligence had counted them as destroyed. Even American naval officers questioned whether the resources devoted to salvage might be better spent building new vessels. The Maritime Commission was already accelerating Liberty ship production. Shouldn't the Navy focus forward rather than resurrect the past? Wallin argued otherwise. Each battleship represented 30,000 tons of displacement, 8 16-inch guns, armor protection nothing else possessed, and most critically, time. Building a new battleship required 3 years. Refloating these vessels might take 6 months. 6 months versus 3 years. The mathematics favored salvage overwhelmingly. But mathematics didn't account for the technical unknowns. No one knew if electrical systems submerged in salt water for months could ever function again. No one knew if the massive turboelectric drives powering California and West Virginia could be salvaged. No one knew if armor plates cracked by torpedo detonations would hold during future combat. The entire operation represented an engineering gamble without precedent. Nevada came first. She had beached herself at Hospital Point during the attack, then been towed across the channel and deliberately sunk at Waipio Peninsula to clear the harbor entrance. Of all the sunken battleships, Nevada represented the simplest salvage challenge. If simple applied to refloating 29,000 tons of war-damaged steel. Navy divers began descending into Nevada's hull in January 1942. The ship had taken 1 torpedo hit and 6 bombs. The torpedo had blown a hole approximately 10 feet across on her port side. Bomb damage had wrecked portions of her superstructure and punctured her deck in multiple locations. But her basic structural integrity remained sound. The question centered on whether she could be made watertight enough to pump out. The dive teams worked in shifts around the clock. Each diver entered the water wearing standard equipment: canvas suit, brass helmet, weighted boots, and descended into complete darkness. Oil covered everything, making surfaces slippery and reducing visibility to arm's length. The divers felt their way through compartments, identifying damage, locating bodies, and mapping the interior for salvage teams. Lieutenant Commander H.E. Haynes supervised all diving operations. He implemented strict safety protocols after the first fatalities. Every compartment would be ventilated before entry. Every diver would carry litmus paper to detect hydrogen sulfide. No one would work alone. The protocol slowed operations but kept men alive. The salvage team began sealing Nevada's compartments one by one. Watertight doors were closed and dogged shut from outside. Smaller holes were plugged with wooden wedges driven tight and sealed with tar. The major torpedo damage required a steel patch welded directly onto the hull underwater, an operation requiring incredible precision. Welders worked from a floating platform while divers guided the patch into position and held it steady. The first patch leaked. The second held. By early February, Nevada was ready for refloating. Pumps began removing water from her interior compartments. For 3 days, pumps ran continuously while engineers monitored her buoyancy. Water levels dropped. The ship's weight decreased. On February 12, Nevada stirred. Her hull lifted slightly off the bottom. By February 14 she floated. Admiral Nimitz and Rear Admiral William Furlong stood with a cheering crowd as tugs towed Nevada to Dry Dock No. 2. The operation had taken roughly 6 weeks from start to finish, far faster than anyone had predicted. Nevada would steam to Puget Sound Navy Yard for final repairs and rejoin the fleet by October 1942. But Nevada was the easy one. California and West Virginia presented problems an order of magnitude more complex. California had been hit by 2 torpedoes and 1 bomb. She had settled to the harbor bottom with her main deck completely submerged and portions of her upper deck underwater. The torpedo hits had blown massive holes in her port side. Unlike Nevada, patching those holes underwater proved impossible. The damage extended too far and too deep. Wallin's team constructed wooden cofferdams instead. These enormous structures rose from below the waterline to several feet above the water's surface, creating sealed compartments around the damaged sections. Carpenters built them in sections on shore, floated them into position, and secured them to California's hull with steel cables while divers worked underneath to seal the bottom edges. The cofferdams transformed California into a bizarre hybrid, part warship, part wooden fortress. Once sealed, pumps could remove water from inside the cofferdams faster than it leaked through the seals. Slowly the water level dropped. The damaged hull became visible. More pumps were brought in to handle the ship's interior compartments. California carried turboelectric drive. Her propellers were powered by electric motors fed by massive generators. The entire system had been submerged in salt water for months. Conventional wisdom said electrical equipment couldn't survive total immersion. The Navy flew in specialists from General Electric in Schenectady, New York. Engineers spent the entire summer of 1942 disassembling, cleaning, and rewiring miles of electrical cable. They focused on getting 1 alternator and 2 motors operational, just enough to move the ship under her own power. California was refloated on March 24, 1942. She entered Dry Dock No. 2 on April 9, where repair crews discovered the full extent of her damage. The torpedo holes gaped wide enough to walk through. Sections of her hull had buckled from the force of the explosions. 9 of her 12 14-inch guns had been removed to reduce weight during salvage. The reconstruction would take months. California departed for Puget Sound on October 10, 1942, moving under her own power, a testament to the GE engineers' work. She wouldn't return to combat until January 1944, but she would return. West Virginia represented the ultimate salvage challenge. She had taken 7 or possibly 8 torpedo hits along her port side, plus 2 bombs. Her rudder had been blown completely off. Over 200 feet of her port hull had been destroyed, not damaged, destroyed. The salvage officer's official report stated the damage was so extensive as to beggar description. Moreover, West Virginia had burned for 30 hours after the attack. Fire had buckled her deck plating for 3/4 of her length. The heat had warped bulkheads and destroyed equipment throughout the superstructure. Oil fires had spread from the burning Arizona nearby, feeding on West Virginia's own leaking fuel. The ship had settled into 40 feet of water, listing slightly to port, her hull crinkled and compressed from the weight. 70 bodies remained inside. Unlike California or Nevada, many of West Virginia's dead had survived the initial attack only to die trapped in sealed compartments as air ran out and the ship flooded from below. The salvage crews found evidence of desperate survival efforts: watertight doors sealed from inside, emergency rations consumed, and that terrible calendar marked through December 23. The salvage operation began with the grimmest work: body recovery. Divers entered compartment after compartment, removing remains while trying to maintain the dignity owed to fallen sailors. The psychological burden was immense. These weren't anonymous dead from centuries past. These were shipmates, brothers, friends who had died just months before in spaces so close yet unreachable. The technical challenges surpassed anything attempted with California. West Virginia's torpedo damage extended from frame 43 to frame 97, an enormous section of the midship area. The salvage team designed two massive cofferdams, one covering frames 43 to 52 forward, another spanning frames 61.5 to 97.5 amidships. These weren't simple wooden barriers but complex engineering structures built to withstand the pressure of millions of gallons of water. The forward cofferdam took weeks to construct. Carpenters worked from floating platforms, building the structure section by section while divers sealed the bottom to the ship's hull. The amidships cofferdam dwarfed the forward one. It covered nearly the entire length of the ship's port side where torpedoes had struck. The wooden structure extended high above the waterline, creating what looked like a second hull built around the damaged warship. Pumping began in spring 1942. The operation required coordination between multiple pumping stations, each feeding enormous volumes of water out of West Virginia's interior. Engineers monitored water levels continuously, adjusting pump output to maintain balance and prevent the ship from rolling. The slightest miscalculation could cause catastrophic structural failure or capsize the vessel entirely. West Virginia broke the surface on May 17, 1942. The ship that Japanese intelligence had declared destroyed, that American officials had written off as a total loss, floated. Her port side remained a twisted ruin hidden behind massive wooden cofferdams, but she floated. Tugs moved her carefully to drydock number 1 on June 9, where the true scope of both the damage and the accomplishment became visible. The cofferdam removal revealed devastation that should have meant permanent destruction. One torpedo had struck the armor belt 3 feet above its lower edge, burning an 18 to 20-inch circular groove into the armor for about 270 degrees. The pressure wave had blown hull structure inward 8 to 10 feet below the belt. Additional torpedoes had simply obliterated sections of the hull. There was no structure left to repair, only empty spaces where steel should have been. Multiple armor plates, each weighing tons, needed complete replacement. The entire port side structure from the turn of the bilge to the boat deck required rebuilding. Over 200 feet of the ship's length demanded reconstruction from the frame inward. The Navy Yard workers approached what amounted to building half a new ship while retaining the other half. But something unprecedented emerged during California's salvage that transformed the entire operation. Submerged electrical equipment could be recovered. When Nevada's salvage crews first energized her electrical systems after months underwater, engineers expected total failure. Instead, after proper cleaning and drying, the equipment functioned. The discovery revolutionized salvage doctrine. Commander Hyman Rickover, who would later become the father of the nuclear navy, led the effort to recover California's turboelectric drive. His team developed procedures for disassembling motors and alternators, cleaning each component with fresh water, drying everything completely and reassembling the systems. The work required meticulous attention to detail and expertise most salvage operations never demanded. But it worked. Motors that had been completely submerged in salt water for months spun up and generated power. This revelation extended beyond Pearl Harbor. It meant future naval battles wouldn't automatically result in total ship losses. It meant vessels damaged and flooded could potentially be recovered even after extended submersion. The implications for naval warfare were profound. What had seemed like killing blows might only be wounds. The salvage operation also revealed Japanese intelligence failures. Tokyo had counted 8 battleships destroyed or permanently out of action. Their battle planning assumed those vessels would never threaten Japanese operations. But by mid-1942, Pennsylvania, Maryland, and Tennessee had returned to service. Nevada was undergoing final repairs. California and West Virginia, though requiring extensive reconstruction, were salvageable. Only Arizona and Oklahoma represented actual total losses, and even Oklahoma was eventually refloated, though too damaged for repair. The mathematical reality shifted dramatically. Japan had temporarily removed 8 battleships but had only permanently destroyed 2. The 6 survivors, when returned to service, would come back modernized and improved. West Virginia and California would receive new anti-aircraft batteries, updated fire control systems, improved armor protection, and enhanced torpedo defense. They would return to the war more capable than when they left it. Meanwhile, the salvage expertise developed at Pearl Harbor spread throughout the Navy. Damage control teams incorporated lessons learned from refloating sunken battleships. New protocols for managing flooding and toxic gases became standard procedure. Pump configurations that worked at Pearl Harbor were replicated fleet-wide. The engineering solutions developed by Wallin's Salvage Division influenced naval architecture and damage control doctrine for decades. But the revelation extended deeper than technical accomplishments. The salvage operation represented something fundamental about American industrial capacity and national character. When confronted with what appeared to be irreversible disaster, the response wasn't acceptance but defiance. Ships that couldn't be raised were raised. Electrical systems that couldn't be recovered were recovered. Damage that should have meant total loss was repaired. Japanese planners had calculated that destroying America's battleship force would cripple offensive operations for years. They had failed to account for American engineering audacity combined with industrial capacity. While salvage crews worked around the clock at Pearl Harbor, shipyards on the mainland accelerated construction. The Maritime Commission's Liberty Ship program reached peak efficiency, launching new vessels faster than German U-boats could sink them. New Essex-class carriers slid down the ways. Destroyer production accelerated. The salvage operation bought precious time while new construction ramped up. By late 1942, the strategic balance had shifted. The Battle of Midway in June had eliminated 4 Japanese carriers. The Solomon Islands campaign was grinding down Japanese air and naval strength. And the Pearl Harbor battleships were returning. Nevada steamed back into service in October 1942, just 10 months after the attack. She immediately deployed to support the Aleutian Islands campaign, then transferred to the Atlantic for convoy escort duty before returning to participate in the invasion of Normandy. Her 14-inch guns would bombard German positions on D-Day, a mission no one could have imagined on December 7, 1941. Tennessee and Maryland, less severely damaged, had returned to action even faster. They participated in the Battle of the Philippine Sea in June 1944, helping to annihilate Japanese carrier air power in what American pilots called the Great Marianas Turkey Shoot. The very ships Japanese commanders thought they had eliminated returned to destroy the Imperial Japanese Navy's offensive capability. But the most dramatic return belonged to West Virginia. After her refloating in May 1942, she spent months in dry dock at Pearl Harbor receiving temporary repairs sufficient for the voyage to Puget Sound Navy Yard. She departed under her own power on April 30, 1943, a sight that must have seemed impossible 18 months earlier. Workers at Pearl Harbor, many of whom had descended into her flooded compartments and emerged covered in oil and filth, lined the docks to watch her leave. At Puget Sound, West Virginia underwent the most extensive reconstruction any battleship had received. New armor plates replaced torpedo-damaged sections. Her superstructure was completely rebuilt with improved designs. New anti-aircraft batteries transformed her into a floating fortress against kamikaze attacks. Updated radar and fire control systems gave her targeting capabilities that exceeded her original specifications. When she emerged from reconstruction in September 1944, she was, in many respects, a new ship wearing her old name. West Virginia's return to combat came during the invasion of Leyte Gulf in the Philippines in October 1944, one of the largest naval battles in history. On the night of October 24 to 25, during the Battle of Surigao Strait, she helped spring a perfectly executed ambush against Japanese forces. Using her new radar fire control system, West Virginia opened fire at a range of 22,800 yards, over 12 miles, and scored hits with her first salvo. Her 16-inch guns, salvaged from Pearl Harbor's muddy bottom, helped sink the Japanese battleship Yamashiro. The irony was complete. A ship torpedoed and left for dead at Pearl Harbor returned to destroy a Japanese battleship using the same guns that had rested underwater for 6 months. West Virginia went on to support operations at Iwo Jima and Okinawa, where her anti-aircraft batteries shot down multiple kamikaze aircraft attempting to crash into American vessels. On September 2, 1945, West Virginia sat anchored in Tokyo Bay as Japanese officials signed the surrender documents aboard the battleship Missouri. Her presence symbolized something beyond military victory. She represented the transformation of apparent defeat into ultimate triumph. The ship Japan's intelligence had counted as destroyed participated in Japan's surrender. The salvage of USS Oklahoma represented the most challenging operation of all, not because she would return to service but because she wouldn't. Oklahoma had capsized completely during the attack, rolling onto her port side at an angle of approximately 150 degrees. Her starboard side pointed skyward like the belly of a dead whale. She had taken 5 torpedoes in rapid succession, and the flooding had occurred so quickly that damage control was impossible. 429 men died in the attack, many trapped inside as the ship rolled. Unlike the other sunken battleships, Oklahoma's salvage served a different purpose. Navy planners determined early that returning her to combat status was impractical. The capsized hull blocked a critical mooring berth. The salvage would clear the berth and potentially recover weapons and equipment, but Oklahoma herself would never fight again. The engineering problem bordered on impossible. Battleships weren't designed to be righted after capsizing. Oklahoma weighed over 29,000 tons and rested at a severe angle on the harbor bottom. Her port side, buried in mud, had to be extracted without breaking the hull apart. The slightest miscalculation during the righting process could cause catastrophic structural failure, potentially breaking the ship in half or causing uncontrollable rolling that might capsize her onto her opposite side. Commander F. H. Whitaker oversaw the Oklahoma salvage operation, beginning work in earnest in mid-1942 after the more immediately critical salvage jobs were complete. His team developed an ingenious solution. They would pull Oklahoma upright using a system of enormous winches anchored on Ford Island. But the system's scale exceeded anything previously attempted. Engineers designed and constructed 21 massive righting frames, called bents, that were welded to Oklahoma's exposed starboard hull. These steel structures rose from the ship's side like enormous triangular supports. Each bent had to be precisely positioned and secured to bear tremendous loads during the righting operation. Steel cables connected each bent to electric winches mounted on Ford Island, roughly 50 yards away. The winches themselves represented engineering marvels. Each could pull with over 100 tons of force. But pulling Oklahoma upright required coordinated operation of all 21 winches simultaneously, maintaining precise tension ratios to prevent uneven rolling. A single winch failure or miscalculation could cause the entire operation to fail catastrophically. Before righting could begin, Oklahoma had to be lightened. Salvage crews removed fuel oil, pumping out thousands of gallons of bunker fuel mixed with seawater. Ammunition was extracted, an operation requiring extreme caution given the ship's instability. Heavy equipment and machinery were removed where accessible. Every pound eliminated made the righting operation marginally less impossible. The actual righting process began in early 1943 and proceeded in agonizingly slow increments. The winches would pull for several minutes, rolling Oklahoma a few degrees, then stop for assessment. Engineers monitored hull stress, checking for signs of structural failure. If the hull could withstand the strain, pulling resumed. If stresses exceeded safe limits, the operation halted while crews adjusted tension or reinforced weak points. Oklahoma moved degree by degree. 5 degrees. 10 degrees. 20 degrees. Each increment took days or weeks. The ship groaned and creaked as steel compressed and expanded under loads never anticipated by her designers. Welds held. Frames flexed but didn't fail. The harbor bottom released its grip on her port side inch by inch. By June 1943, Oklahoma had been righted to approximately vertical. The capsized Leviathan now floated upright, though her port side remained extensively damaged and most of her interior was still flooded. Pumps began removing water, preparing her for dry dock. The operation that many engineers had considered impossible, righting a capsized battleship, had succeeded. Oklahoma entered dry dock where crews discovered the full extent of her damage. The torpedo hits had destroyed major structural elements. Fire and flooding had ruined equipment throughout the ship. Corrosion had advanced during the months she lay capsized. Even simple repairs would require essentially rebuilding the vessel from the hull up. The Navy made the final determination. Oklahoma would be stripped of useful equipment and decommissioned. Yet the operation itself represented a triumph. The engineering techniques developed during Oklahoma's salvage, particularly the righting frame and coordinated winch system, became standard procedure for future salvage operations worldwide. When future naval disasters occurred, salvage teams would reference the Oklahoma operation as proof that even apparently impossible recoveries could succeed. The psychological impact of Oklahoma's salvage resonated throughout the Navy. If a completely capsized battleship could be righted, then virtually any damaged vessel could potentially be recovered. The salvage mentality shifted from assess if recovery is possible to determine how recovery will be accomplished. This philosophical change influenced damage control doctrine and naval culture for generations. During Oklahoma's righting, salvage crews discovered something that haunted everyone involved: more bodies. Men who had survived the initial attack had died slowly in sealed compartments as the ship capsized. Some had reached air pockets and survived for hours or even days before water levels rose or air ran out. The recovery of these remains became a somber reminder of what the salvage operation represented, not just reclaiming ships, but honoring the men who had served aboard them. The Pacific Theater's strategic situation had transformed entirely by mid-1943. American forces had secured Guadalcanal after 6 months of brutal fighting. The Solomon Islands campaign was turning the tide. New carriers and battleships were joining the fleet faster than losses could accumulate. Japanese industrial capacity couldn't match American production. The salvaged Pearl Harbor battleships represented bonus assets that accelerated the inevitable. California returned to combat in January 1944, immediately deploying to support the Marshall Islands invasion. Her 14-inch guns bombarded Japanese positions on Kwajalein and Eniwetok. She participated in the Battle of the Philippine Sea in June, then supported operations at Guam, Tinian, and Peleliu. Every operation she participated in was one more operation the Japanese had believed she would never reach. The salvage operation's true climax came at the Battle of Surigao Strait. On the night of October 24 to 25, 1944, 6 American battleships formed a battle line across the strait's northern end, a classic naval maneuver straight from the pre-war tactical playbooks. 5 of those 6 battleships had been damaged or sunk at Pearl Harbor. West Virginia, California, Tennessee, Maryland, and Pennsylvania had all been hit during the attack. Only Mississippi had escaped Pearl Harbor unscathed. Japanese Rear Admiral Shoji Nishimura led a force of 2 battleships, 1 cruiser and 4 destroyers into what became a perfectly executed ambush. American destroyers attacked first with torpedoes, damaging several Japanese vessels. Then the battleships opened fire. West Virginia's radar-directed salvos struck Yamashiro from over 12 miles away. California and Tennessee added their fire. The Japanese battleship Fuso exploded and broke in 2. Yamashiro sank shortly after. The battle lasted less than an hour. Japanese forces were annihilated. And 5 of the 6 victorious American battleships were vessels that Tokyo had counted as destroyed 3 years earlier. The ships raised from Pearl Harbor's muddy bottom had just executed one of the most one-sided naval victories in history. By the time Japan surrendered in September 1945, every salvaged Pearl Harbor battleship except Oklahoma had contributed to the war effort. The statistics told a remarkable story: 21 American ships damaged or sunk during the attack. 18 returned to service. The 3 permanent losses, Arizona, Oklahoma, and Utah, represented the only complete Japanese successes. The salvage operation's scope and speed had exceeded all projections. Captain Wallin's initial estimates suggested the operation might take 2 to 3 years. The most critical work was completed in less than 18 months. Nevada returned to service in 10 months. California in 25 months. West Virginia in 33 months, though most of that time involved extensive modernization rather than simple salvage. The diving work alone represented an achievement unmatched in maritime history. Navy and civilian divers logged approximately 20,000 hours underwater across roughly 5,000 individual dives. They worked in near-zero visibility through oil-fouled water, descended into gas-filled compartments, and performed underwater welding, cutting, and construction. Only 3 divers died during the entire operation, a remarkably low casualty rate given the hazardous conditions. The Pearl Harbor Navy Yard proved as critical as the salvage division itself. Yard workers performed permanent repairs on vessels after refloating, often while supporting the active fleet's ongoing operations. The yard's capacity to simultaneously handle combat repairs, salvage support, and routine maintenance enabled the entire operation. Rear Admiral Claude Gillette, the Navy Yard manager, became intimately involved in reconditioning the complex turboelectric drives that powered California and West Virginia. The salvage taught lessons that reverberated throughout the Navy. Electrical equipment could survive saltwater immersion if properly treated. Hydrogen sulfide posed lethal hazards requiring constant monitoring. Wooden cofferdams could seal enormous hull breaches when steel patches proved impractical. Coordinated pumping operations could refloat vessels sitting in mud under 40 feet of water. Most importantly, ships were more survivable than peacetime doctrine had assumed. These lessons influenced wartime operations immediately. The cruiser Houston survived multiple bomb hits because damage control teams applied Pearl Harbor salvage techniques to keep her afloat long enough for repairs. The carrier Yorktown remained operational after the Battle of Coral Sea because her crew had trained using salvage-derived damage control procedures. Throughout the Pacific War, vessels that might have been lost instead returned to service, often within weeks. The Japanese never fully grasped what happened at Pearl Harbor. Their intelligence services continued reporting the destroyed battleships as permanent losses even as those same ships participated in battle. The appearance of Nevada during the Normandy invasion reportedly shocked German coastal observers who believed American battleship strength remained crippled from Pearl Harbor. The psychological impact of seeing destroyed vessels return to combat undermined Japanese confidence in their intelligence assessments. By war's end, the salvaged battleships had compiled impressive service records. Nevada participated in both the Atlantic and Pacific theaters, supporting amphibious operations from Normandy to Okinawa. California fought in every major campaign after her return, earning 7 battle stars. Tennessee earned 10 battle stars across multiple operations. Maryland participated in nearly every significant Pacific engagement after her repair. Pennsylvania, the fleet flagship that survived Pearl Harbor in drydock, served continuously throughout the war despite taking torpedo damage from a Japanese submarine just days before the final surrender. West Virginia's record proved most dramatic. After her resurrection from the Pearl Harbor mud, she participated in operations at Leyte Gulf, Lingayen Gulf, Iwo Jima, and Okinawa. Her anti-aircraft crews shot down multiple kamikaze aircraft. Her 16-inch guns bombarded Japanese positions across the Pacific. When she anchored in Tokyo Bay for the surrender ceremony, she carried battle stars and citations that would have seemed impossible in December 1941. Admiral Nimitz presented Captain Wallin with the Distinguished Service Medal in July 1942, reading the citation on the deck of the carrier Enterprise. He concluded by calling Wallin an undying optimist. Wallin accepted the medal on behalf of the entire salvage organization. The divers, engineers, welders, carpenters, electricians, and Navy Yard workers who had accomplished what many considered impossible. The operation's financial impact was equally significant. Building a new battleship cost approximately $100 million in 1940s dollars and required 3 years. The entire Pearl Harbor salvage operation, covering multiple battleships and other vessels, cost roughly $20 million. The Navy gained 6 battleships in a fraction of the time at a fraction of the cost of new construction. From a purely economic standpoint, The salvage operation ranked among the most cost-effective military undertakings of the entire war. Post-war analysis revealed additional Japanese mistakes. Their attack had focused on battleships, the wrong target. The Pacific War would be won by carriers, submarines, and amphibious forces, all of which survived Pearl Harbor largely intact. The Japanese had inflicted maximum damage on vessels that represented yesterday's naval warfare while failing to destroy tomorrow's. 3 American carriers, Enterprise, Lexington, and Saratoga, were at sea during the attack and escaped damage. Those carriers, plus new construction, would annihilate Japanese naval aviation at Midway, the Philippine Sea, and Leyte Gulf. But Pearl Harbor had psychological consequences beyond its military impact. The attack unified American public opinion like nothing else could. Salvaging the battleships became symbolic of American resilience and determination. When West Virginia returned to Tokyo Bay for the surrender, she represented more than military might. She symbolized a nation that had transformed disaster into triumph through ingenuity, determination, and industrial power. On December 7, 1941, Japanese commanders believed they had crippled American naval power for years. By September 2, 1945, those same commanders stood on the deck of USS Missouri, surrendering to a fleet that included ships they had thought destroyed. The journey from Pearl Harbor's muddy bottom to Tokyo Bay's surrender ceremony represented one of history's most remarkable engineering and industrial achievements. The salvage operation succeeded because it combined multiple American strengths: engineering creativity, industrial capacity, and unwavering determination. When conventional salvage techniques proved inadequate, engineers invented new ones. When specialized equipment didn't exist, manufacturers created it. When skeptics declared operations impossible, salvage crews proved otherwise. The technical innovations developed at Pearl Harbor influenced maritime salvage for decades, establishing procedures still referenced today. But the operation's significance transcended engineering. The refloated battleships became symbols of national resilience. Newsreels showing sunken ships rising from the harbor appeared in theaters nationwide, providing tangible evidence that Pearl Harbor's damage could be reversed. Every salvaged vessel represented a psychological victory that matched its military value. The men who performed the salvage rarely received recognition proportional to their achievement. Divers who descended into poison darkness, welders who worked underwater on damaged hulls, carpenters who built massive cofferdams, engineers who reassembled submerged electrical systems. These sailors and civilians operated far from combat zones and headlines. Yet their contribution proved as essential as any battle. They transformed defeat into opportunity and disaster into determination. Captain Wallin retired from the Navy in 1956, having served through both World Wars and Korea. He rarely discussed his Pearl Harbor salvage work, viewing it as simply doing his job under difficult circumstances. But historians recognize the operation as one of the war's pivotal achievements. A victory won not with weapons but with pumps, cofferdams, and relentless engineering problem-solving. The salvaged battleships themselves had varied post-war fates. Most were decommissioned and scrapped by the early 1960s, their war service complete. Nevada survived to become a target ship for atomic bomb tests at Bikini Atoll, absorbing multiple atomic and conventional weapons before finally sinking in 1948. California was scrapped in 1959. Tennessee met the same fate in 1959. West Virginia lasted until 1961 before going to the breakers. Today, only Arizona remains at Pearl Harbor, her hull resting where she sank, transformed into a memorial. The sunken battleship that couldn't be salvaged became the lasting symbol of December 7, 1941. But the ships that were raised, rebuilt, and returned to service told a different story, one about engineering audacity, industrial capacity, and national character. The ghost fleet of Pearl Harbor didn't stay ghosts. They rose from the harbor bottom, rebuilt themselves, and returned to sink the navy that thought it had destroyed them. In the annals of military engineering, few operations matched the Pearl Harbor salvage for technical innovation, strategic impact, and sheer improbability. Ships that Japanese commanders counted as destroyed participated in Japan's surrender. That reversal, from catastrophe to triumph in less than 4 years, defined not just the salvage operation but the entire Pacific War. The question was never whether the ships could be raised. The question was whether anyone had the audacity to try. Captain Wallin and his salvage organization answered with pumps, cofferdams, and thousands of hours of work in darkness and oil. The Ghost Fleet sailed again, and with them sailed proof that American industrial might could overcome even the most devastating surprise attack.